Today I'll show you guys a little bit about reference frames and the midterm review. The first part, reference frames, will not be on the exam, but I'll cover that just so you guys have that, and we'll move on into the midterm review. Again, reminder that midterm is on Thursday, and it'll start promptly at 7:30. So other than that, we have no major announcements, and so we'll just move right on into contours. Contours, these are basically lines that delineate elevation on a map, and so you can look through each of these. That they're just basically each elevation has a specific line associated with that. Because of that, they should not be they should not intersect unless a very unique situation occurs, such as a cave under a cliff or something of that nature. So they are perpendicular to the macro direction of the slope. So you think of the direction that water would run down would be perpendicular to the contour lines. Now in general, you can see that they, from that top view there, looking down, you can see the contour lines, and then this represents what kind of hill that is. So on the top portion, you can see that without the elevations listed, if there was no elevations listed on that, you couldn't tell whether that elevation was going up towards the middle of those circles or whether it's going down. And so in order to figure out whether it's a valley or a hole or a mountain, you really need to have the elevations on there to give a specific description of that. Again, here's another example of just the different features that we can have in contours. And so you've got everything from hill, valley, ridge, all the way down to cut and fill. We hope they're okay. When I get back, I will do an example with you guys on contours, but that's just kind of a brief introduction to it. The example will just kind of help us fill in some of the gaps there. Next thing is stationing. In construction of infrastructure, especially with roadways, you're going to see stationing. It is the road ruler for infrastructure. So typically you talk about feet, but now we will talk about stationing when you're on a construction site. So with stationing, you'll see that basically it's a measure of hundreds of feet. So if our starting point for a specific job, if we're on the road between Pullman and Spokane, we're doing a job on the highway there, and the starting point for that job over a certain section of highway, we would set that as 0 plus 0, 0. That just means 0 feet, and then we would move to 1 plus 0, 0, which is 100 feet. So basically, you just take your whatever feet measurement it is from the original starting point, and you're going to take that feet, and you'll basically take the hundreds off of there and just add a plus to it. And so you can see down there with 6 plus 4, 2.97 is 642.97 feet. Fairly simple on the orientation of, or the notation, I'm sorry, of stationing. You'll see it used all the time in infrastructure, specifically roads. So here's just an example of where you have stationing. This would be where two straight roads come together and you got some sort of curves connecting those, and so you can see at the beginning here, this would be point of commencement, point of curvature for that roadway, 9 plus 82.71, so that's 982.71 feet. And then we'll move along there until you get 16 plus 0, 0 here, so that's 1,600 feet, move to 1,700 feet, and then the point of tangency here is 1,816.04 feet. So the start of this then would be back here down this line here, the start of that specific job site. So used fairly frequently in that, and again we have another example that we'll cover when I get back. So that stuff that we covered there is just real easy, and then we'll move on to review here. So as we look at the review topics for the exam, I just want to let you know that these will be two different categories. Some of these will be basically an explanation or a conceptual piece, and then the other ones will be calculation pieces. So the conceptual pieces are just testing you to see if you know the difference between things, how to describe something, basically have a fundamental understanding of how something works. The calculation pieces are basically specific calculations that we've gone over in homework, in class examples, things of that nature. So in general, we just want you to be able to describe surveying and what it's all about. I've given you a basic definition. Can you give your own definition for that? Second one there is the difference between a plane survey and a geodetic survey. So this is the difference between 2D and 3D and a projection between the two. And so what happens when we take a three-dimensional survey and take it into a planar? We have some distortion there, and make sure you understand the differences there. With geodetic datum, this is basically when we were looking at sea level, how that's performed and what is our datum for that geodetic three-dimensional surface. It's different than a datum for just a two-dimensional surface, a planar. Typically with the datum there, you're looking at kind of the XY coordinates. And so our datum is that origin there. It's different when we get into 3 dimensions, dealing with the sea level and the different pieces there. So next would just be different types of surveys that we might use, just being able to look at different examples there. Next is measurements. Measurements is a big piece of surveying. We want to be able to know what type of measurements we have and be able to convert between measurements. And so within that, there's different pieces, specifically with conversion, just going between English and metric, and then also the degree conversion from decimal degree and back to degrees, minutes, and seconds. Also significant figures. We spend a good amount of time on significant figures. Make sure you are able to use all the rules that we looked at and be able to calculate the significant figures of specific measurements. Also with measurements, this is the specific items for the significant figures. So we got about 5 rules there. Make sure to look over each of those rules for the coming exam. It'll just there was an example sheet that in-class example that we did a lot of these on, and just make sure to you know how to deal with each of those there. Also, just make sure that top one with multiple units or fractions are given. If I have a tape measure and give feet, inches, and then portions of an inch, how do I know what the significant figures on that are? Error of measurements. We talked a lot about the standard deviation and what that actually means. Make sure you know what standard deviation actually represents, and then using that with different elements. So the sum of or 50%, 90%, 95% errors, and what that means when we're talking about a confidence interval. When we're dealing with propagation of errors, this was an in-class exercise when we did the perimeter and area of a rectangle. How do we take errors with measurements of the sides and add those together, or for perimeter, or with multiplication with the perimeter? How do you deal with those? And then big piece here is the types of errors. What's the difference between systematic, random, and user errors? Each of these is very specific. With systematic, we're really looking at something that can be accounted for with a calculation. So if you're off in the EDM, if the optics are off, you can calculate how far they're off and what that measurement should have been. For random error, this is eyesight, or the limitation on optics, where we can't really account for that with a calculation, but you can account for it with probability and statistics. And then user errors, this is just when somebody makes a mistake and there's no way to really back out that, because we don't know exactly what that mistake was. Also there, understand and describe the types of errors evident in surveying measurements. So just being able to give examples of what kind of measurements or errors you'd see in surveying itself. Angles. I talked a lot about angles. Specifically with surveying, you're going to hear these terms backsite and foresite. That is specifically for angles. If we are set up our total station and look back to a known location, that is looking back to our backsite, and then we take an angle measurement to our foresite. So just knowing those terms and why we use backsite and foresight, and understand the difference between true and magnetic north. So a very fair question is asking about if I'm looking at a bearing from magnetic north rather than from true north, how would I calculate that? We're very used to using true north, but with a magnetic north, if I give you a declination, again, declination is the difference between true and magnetic north there. Azimuth and bearing, make sure you know which one is which, and how to calculate those and convert between those. And then finally on the bottom there, the angles to the right. So we covered this extensively. The angles to the right is used when we're going, say, to make a triangle, and I'm looking at the angles that are given there that are measured by my total station. When I say angles to the right, make sure that you can reproduce the measurements graphically that are given numerically on a page, or vice versa. Property description. So we talked about different pieces of this, starting with kind of meets and bounds. This is as you're walking around the perimeter of a property, could you create a meets and bounds property description from a given plot that's graphically depicted, and what needs to be in place there for meets and bounds. There are 6 items that you should review that need to be in place for meets and bounds. And then bottom 2 there is talking about the public land survey system, and so this involves the township range and section information, as well as down to quarter sections, obviously starting at a meridian. And so make sure you can locate a certain point based on a given public land survey system notation there, and especially talking about the areas or distances between 2 points there. Again, this is what you guys will see on the exam. Fairly basic. We covered this in class already. Pretty brief there. Do make sure to bring your calculator with you. Although if you don't, you can just draw your calculations as far as you can. And you guys do get that one sheet of notes, both sides. So this is a really brief overview of the exam. If you do have questions over the next couple of days, please feel free to email me, kolson@wcu.edu, as well as I will be sending out some information for you guys to start logging on to the virtual server, as we will need that for Thursday. So please do, when you get a chance, go ahead and look at the virtual server instructions that are on the website, and try and connect to that before Thursday so that you don't have to waste your time trying to get onto the computer. So again, if you have trouble getting onto the VMware, please let me know, and I will do the best I can to help you out, or connect you with John Haywood, who is our computer technician, to get you set up there. So thanks for listening. Good luck on the exam, and there will be somebody there at 7:30 to make sure you guys are set to go. So good luck.